video, I want to give my top 5 learning strategies or frameworks for any student out there, university, college, school. And this is based on thousands of hours of tutoring experience and what I've found has worked and hasn't worked. So number 1, the best learning method I think out there is matrices. And I'm not talking about the matrices you learn in maths. I'm talking about basically a 2x2 or 3x3 table with qualitative and or quantitative information. This is based on when I worked in strategy consulting, we love using matrices in client decks because oftentimes when we would be gathering market intelligence, it's highly qualitative in nature. It's based on hundreds of hours of conversations with various stakeholders in a project. And trying to collate and summarize all that information can be pretty tricky. The same thing applies in any really kind of subject, whether that be STEM, humanities, or anything in between. You often have a lot of quantitative data. Trying to make sense of it can be challenging. What I have found is using a simple 2x2 or 3x3 matrix, where you simply just each box, so you have rows and columns, which represent various variables or transient states in time. And basically the boxes in between are your unknowns or knowns, and you just fill it out. I found that putting information into this format really helps a student understand and digest what's going on and make sense of what can be sometimes really challenging case studies with reams of information. The second is ratios. I'm a big fan of ratios, and I believe in a lot of science, specifically physics, those problems can be solved with ratios. So all you need to know is if A is directly proportional to B, or A is inversely proportional to B, you can replace the proportionality sign with an equal sign multiplied by a constant proportionality. And then using this, you can use this to sort of hop between two different scenarios or cases. Because usually they will give you a before and an after. And my students have been saying this all the time. You are usually given 3 out of 4 variables, 3 out of 4 data points, and a simple ratio where A1, B1 equals A2, B2, figuring out which of those things you need to know will help you solve the answer or solve the question. Number 3, and this is my favorite one, this is a glossary. I often say you need to turn English into math or translate. It's just like translating languages, like saying hola is the same as saying hello, right? And the same thing applies with questions. There's a key skill which is basically can you turn a phrase or word into a mathematical condition? And then I make my students write out a whole list of those and memorize it. What's a simple example? If something is at least, mathematically you're saying greater than or equal to, right? And then it could vary in complexity depending on the subject and the case you're looking at. But I'm a really big proponent of converting or translating English into maths, and basically, that's what I would say. Or another simple example is like equilibrium. Sum of forces is 0, sum of moments is 0, right? So not that hard. Number 4, this is one that comes up a lot, and I don't think any teacher or professor teaches this to you guys, and that is the concept of a connective variable. What's a good example of this? Well, first of all, I'll define it. A connective variable is just something that links 2 different points in time. So let's say you have like a transient or temporal case study. So let's say we have a circuit and there's an LDR in series with a fixed resistor, and they give you 2 different points in time where the LDR is at 2 different operating at 2 different intensities, and you sort of have to figure out a characteristic like current or voltage in the second intensity, second mode of operation. So to hop between the first and the second, you need something that connects them. The connector variable is something whose value doesn't change with time. So in this case, the fixed resistor, which is in series with the LDR, will be your connector variable, because no matter what the light intensity is in that circuit, that resistance is always fixed. Developing the skill of identifying the connector variable is such a key skill, and oftentimes people will do it without even realizing they are doing it, if that makes sense. Number 5, the 2-mark explain question. I couldn't think of a good name for this, so I'll just say it as it is. A lot of people drop marks on explain questions because they just blurt and waffle and just throw anything. Any explain question can be summarized can be solved in a 2-step method. 1, state the underlying principle or theoretical concept that is being tested, and then use that concept to explain or connect the dots to what's going on in the question or why a change happens. So start by just stating like the rule or the principle and then apply it to the question. Link it to what's happening, okay? Number 5, we've done number 5, but this is a bonus one, sense checking. And this is specifically for modeling questions. Everyone hates 1 markers at the end of a model question. And a lot of them can be solved by just saying, I say, forget the question for now. Just imagine this was a real life thing. What is the worst case scenario for this and how can we avoid it? Oftentimes, when you think of the worst case scenario and avoiding it, the way you avoid it is usually, at least in maths, some sort of transformation of a function. So whether that be translating in the x or y, stretching by a scale factor, or reflecting. Usually it's the first two. But I'm just saying that for you guys, like if you're ever stuck on a modeling question, it's probably a transformation you need to apply. But before you even get to that point, you need to stop and forget the question and say, what is the worst case scenario here? How can I ensure against it? Okay? For example here, like this bridge. If they said, like if they modeled it, like they gave you a model to show the bridge and they say, what's an improvement? Then maybe if they're in the model, if like that bridge was too low to the water, you would say, in the worst case scenario, forget the thing. I'd say, I wouldn't want to be driving a car when I'm that close to the water. I'd like to be a bit further up, in case something happens. How do I translate that into literally, how do I express that mathematically? Well, I want the bridge to be higher, so it's a translation in the y-axis, right? It's the same thing. If you start to think like that, I promise you modeling questions will not be that hard. Okay? Follow the page for more tips and we'll be dropping more content like this.